This week, we speak with Jack Zarris from Signal Sciences. Today is a double feature of interviews. In our next segment, we'll speak with Tim Mackey from Synopsys. Plus, there's more. We've also started live streaming the show, so hello to everyone hanging out in the Discord channel right now. Stay tuned for Application Security Weekly.
This is a Security Weekly production. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. As the world of software-driven everything becomes a reality and development cycles speed up, sales teams are taking a new approach to application security, one that enables security teams to scale by empowering developers to integrate security into their development workflows and toolsets, all while giving security teams the visibility and control they need. Snyk helps software-driven businesses develop fast and stay secure with a developer-first solution that seamlessly and proactively finds and fixes vulnerabilities in open source libraries and containers. Learn more and see the solution for yourself at securityweekly.com/Snyk. The question is simple. Have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM. Discover a simple way to secure your app without the need for a full security team. With trusted software, simply drag and drop your app and get it back fully protected within a couple of minutes. Trusted software is the smartest zero-touch app protection solution on the market. Change the world one app at a time. With 50 years of security expertise, Erdeto's software security technology and cyber services protect over 5 billion devices and applications for some of the world's best-known brands. To request a demo, visit securityweekly.com/Erdeto.
Welcome to Application Security Weekly. This is episode 108, recorded May 18th, 2020. I'm your host, Mike Shima. I'm here with Matt Alderman. Hello, Matt.
Good morning, Mike.
Good morning, and good morning to John Kinsella. We've got him here as well. Hello, John.
Good morning. How you doing, Mike?
You definitely have had more coffee than both of us, so that's good to hear your voice. Also good to see that you're filling out those bookshelves. So 2 interview segments, no news, so no homework for this week, but we'll make sure to do something for you, John.
I'll come up.
Join us at good. Join us at InfoSec World 2020, June 22nd to 24th, now a fully virtual event. Security Weekly listeners save 15% off the InfoSec World main conference or World Pass. Visit securityweekly.com/ISW 2020. Click the register button to register with our discount code. Learn how hidden vulnerabilities lead to application compromise in our next webcast with Snyk. Register for our upcoming webcasts or virtual trainings by visiting securityweekly.com/webcasts or visit securityweekly.com/on-demand to visit our previously recorded webcasts. Jack Zarris is a senior sales engineer with Signal Sciences. He has over 20 years of experience in the security industry with focuses on web application and database security for on-prem and cloud-hosted apps, product management, load balancing, and mobile device management and security. Hi, Jack. Thanks for joining us.
Thank you very much.
Well, we're definitely happy to have you here, and we'd love to talk about WAFs because of Signal Sciences, obviously, but I think also, too, WAFs in general have moved on quite a bit. They've evolved, so to speak, beyond just inspecting a single packet looking for the old school OWASP top 10 of cross-site scripting and SQL injection. But I'm really curious to talk with you about how have they evolved and what can we be looking at for WAFs to leverage them for now in modern web application threats and vulnerabilities?
Sure. I'm glad you asked the question. So there's a couple different ways that the WAFs have evolved, and it's not just on the detection side. I mean, it's not to say that looking for things like SQL injection, cross-site scripting, command execution aren't important. They are. That's kind of the table stakes of your WAF, but there's a whole array of other attacks and abuses that really have to be looked at. That seem to be the more common and maybe dangerous attacks that have been happening for quite a while now, and WAFs really have been kind of not filling the void very well. And what I'm referring to more is abuse of an application. So an application, if you try to send SQL commands or SQL injection or cross-site scripting, you're trying to break the application, make it do something it's not supposed to do. But with a lot of attacks we're seeing now, the application is being abused, and by that I mean you're making it do things, it's doing things that it's supposed to, like you're supposed to have failed logins, you're supposed to have failed shopping cart checkouts or credit card validations, and you're taking advantage of those things to launch your attack, like again, validate stolen credit card numbers, you use credential stuffing and things like that. And those are things that you cannot detect by looking at single requests. You have to look at the totality or the volume of these things to determine the intent of a failed login versus 2 failed logins versus a credential stuffing attack, as an example.
Like the old day in The Sims, Jack, right? We used to look for 6 failed logins. It would generate an event and say, look, it looks like somebody's trying to brute force our system.
Exactly. But you need to be able to react to that automatically, not send out a log or a notification, and then a human has to react. And by that time, you've already lost the fight. Yes, the notifications have to go out, but the reaction has to be automated as well.
So that's interesting. Let's talk a little bit more about that reaction too. I do want to come back to these types of attacks and types of abuse, because I think it's interesting evolution of what the attacker's doing. But in this reaction, it used to be like if you see an obvious, here's a payload that looks like it's cross-site scripting, we can just block it. Or here's SQL injection, we can just block it. But what does reaction look like when you have these 6 failed logins, or even 6,000, or quite easily someone with a Python script can do 600,000 logins by pulling down some compromised credentials and doing credential stuffing. So what are we talking about here beyond just blocking and trying to one up the attackers?
Right, and I'm glad you brought up the Python script example, because that could also be and we'll get back to this, but I just want to put a mental bookmark in my head. The Python script could be an application developer integrating with your API, and they just get a little too aggressive with the number of API requests they're making over a certain period of time, maybe 10 in a second instead of 10 in a minute, or 100 in a second instead of 100 in an hour. But we can come back to that. That's more abuse kind of by accident rather than on purpose. But as far as the reactions go, when we see abuse like that, like, hey, if I see more than 10 failed credit card validations, or even 100 successful in a certain period of time, that could be evidence of somebody using my application as a proxy to validate their stolen cache of credit card numbers that they can then sell on the black market. Or credential stuffing. Maybe they're not trying to break in your application. Maybe they're just trying to validate which accounts that can be compromised, that are valid, and selling those. And then somebody else is going to come in and take advantage of those. So the way we usually deal with those is you set a threshold to say, if I see too many of whatever behavior that is, I then want to notify somebody and I want to block it. And that's what we're doing today. And that's not just on a single server or in a single container. This is a global threshold. So used to be, attacker could go after a target, say in a data center in North America. If you have multiple data centers, then they get caught there. They go to APAC and then EMEA. And if you had thresholds, if you even had that, you'd have to cross the threshold in multiple places. What we're doing is it's global. If you get caught in one place, every place else knows about it. We can also share that information if you happen to be identified as an attacker with all of our other customers. So you get kind of I guess it's kind of an apropos analogy, but kind of a herd immunity, if you will. If you get tagged as an attacker by one customer, all customers can then be notified that this source is suspect. And you can turn the screws tighter on those sources that already have a bad reputation from us, from SANS. It's a Tor exit node. There's different types of reputation sources. So, but it can still kind of be whack-a-mole, and we can get into more of where we're going to make that the whack-a-mole problem or challenge a little bit harder for the attackers to get past.
Because in order to sorry, Mike, but Jack, from an attack perspective, you have to know a lot about that layer 7 traffic coming in, right? Where it's coming from, sources, are they valid sources, are they known suspicious sources, right? In order to look at that, and then based on certain thresholds that you may set up and say, look, this looks like an attack. Now you're going to put in some response mechanisms. So you have to understand more than just a single payload. You have to understand a whole string of communications coming into that application, right?
Absolutely. Just like any other type of security, it's a layered approach. And can you stop every attack out there? Any security practitioner worth their salt is going to tell you the same thing. Nobody can stop every attack every time. But what you're trying to do is impose cost on the attacker and make yourself an unattractive target as much as possible. So let's start at the top. A completely unknown source, you don't know anything about them, never seen this source before. You can say have a threshold, and let's use the credit card validation as an example. If I see too many failures, maybe from a completely unknown source, if I see 10 failures in a minute, and I'm making up those thresholds, then I'm going to flag that and stop them from any more validations for a certain period of time, maybe 10 minutes. Now, next layer might be if the source is already known and considered malicious by maybe SANS. We import that data fairly regularly and push that out to our agents worldwide. So if it's an IP that has already been identified as malicious by the SANS Institute, I either won't let them validate, or maybe that might be a little too draconian, but I'll say my tolerance for the failed transactions is lower. Maybe it's 2 in a minute. If it's a Tor node, I don't allow that at all, maybe. Or if it's attacked one of our other customers, again, I can turn that dial down to say maybe 1 or 2 in a minute, so be less tolerant. And that information has to be known ahead of time. We have to have mappings of these malicious sources ahead of time, and those have to be dynamically updated constantly for them to be accurate. And that's one of the things that we're doing today and always trying to improve on.
Yeah, I think that resonates a lot with me, and I like that description of trying to both needing to better fingerprint, identify what are these sources, building up reputations around them, as well as raising that cost. Because one of the other ways I've seen, or other approaches, is you could drop a little JavaScript shim into the web page that collects data about that source, but that might be helpful. But that's also not going to be applicable against APIs because the APIs, someone can just directly interact with them and throw some, whatever appropriate cookies or authentication tokens are necessary. So I'm curious then, what have you seen about poking a bit more at that attacker cost? What are some of the strategies you've seen in terms of just blocking attackers one IP address so they can go on to the next one and then the next one and just play that sort of whack-a-mole approach there?
You're absolutely right. I mean, using inserting client-side JavaScript to validate that, it's actually a mobile device or it's actually a desktop. I mean, that's one way to do it. A lot of our customers are kind of adverse to that because sometimes you can break the application. But maybe more importantly is since more and more these web transactions are API-based, especially with mobile devices, that goes out the window. It's just an API now. And inserting client-side JavaScript is not going to work out so well. So you have your security, while that method can work for some customers, your security can't be based on that. So yes, you're doing a whack-a-mole. Even if the source is known, they can go from Tor node to Tor node, they can go from malicious IP to malicious IP, and you're just knocking them off one at a time. what we're researching now, and I don't want to give away too much here because this is not something that we've released yet. But what we're looking into right now is methods of detecting and blocking the attacker without the attacker knowing they've been detected and blocked. Because if I'm attacking, once I see I've been detected and I can't get my request through anymore, I know I need to adjust. I need to change something about the request structure, maybe the user agent, maybe my source IP, what have you. But if we don't let them know that they've been detected, they won't think that they have to move on, and we can continue to stop them. Excuse me, let me clear my throat here. They don't need to move on, so we don't keep playing whack-a-mole. We already got them. They just don't know it yet. So we're protecting the application without the attacker being aware of it. Does that help to make sense without revealing too much?
Yeah. So it sounds like a little deception technique in there to kind of keep them engaged, but not give them any interesting data.
Yeah, I think I talked about it when we were prepping for this, kind of like obfuscated blocking. Now, I won't go into the details of that because we're still researching how best to do it and how that may or may not be possible. But that's the vision, at least in my mind anyway. The whack-a-mole thing it's actually working very, very well for our customers because, let's be honest, I mean, most of the attackers have a limited pool of IPs at their disposal at a given time. And like, say, credential stuffing attack or credit card validation, usually there's millions of them you need to go through. So if you only let them get through a few at a time, it's not all that useful. They can find other sources that are better, that don't have the protections. However, you still want to be able to deal with, especially with IPv6 on the horizon, or for some of the attackers, it's actually out there. Now your attack sources increase exponentially, and now the whack-a-mole game becomes very difficult to win.
Yeah, I think one. Oh, go ahead, John.
First, let's go say I think IPv6 has been on the horizon for about at least 10 or 15 years now.
I know.
Sorry to all the network engineers out there. So one question I have around this, and this is an older question, but I'm sort of curious to see the 2020 Signal Sciences take on it. We're talking about blocking attacker space off IP address. What do you do in the situation where like a large ISP that's doing a lot of NAT? So you might have, or even an office, right? Could be 5 or 10 people behind that, or it could be a lot more. So how do you what's the light touch around that nowadays?
That's a good question. Now, with things like, SQL injection or cross-site scripting, when we flag at a source as malicious and we start blocking them, we're not talking about blocking the IP like blacklisting it. What we're talking about is saying, okay, attacks coming from that source will now be blocked. Now, it's normal traffic, fine, no problem. Something that doesn't contain an attack, and that works fine. Now, if you blacklist it now, you're getting all kinds of trouble. Now, with the things that we've been talking about, like credential stuffing or credit card validation, let's take a college campus as an example. I flag that college campus's IP address and say, hey, I've seen too many failed credit card validations. I am then going to block subsequent credit card validations from that source for the next few minutes. That could affect the entire campus. That's something that you definitely need to be very careful about, because we're doing it based on marking the IP address as malicious or abusive or what have you. We're also looking at ways to say, all right, fingerprint that a little bit farther down to maybe the session or something like that. Now, all these things can be spoofed and changed by the attacker, but you do need, for some applications, you need to get a little bit more granular than just the IP address. And some of our customers, we've been able to do that. The challenge, to be honest with you, with most of the WAFs is in cardinality, where, now instead of thousands, tens of thousands, or hundreds of thousands of sources you need to track as malicious that you're blocking, now you can get into millions of combinations or billions, because you're not just looking at the IP address. And that's something, honestly, we're working to tackle on a large scale, but it's not an easy thing to do. I'll grant you.
Interesting. I know Mike and Matt have a path we want to go with this conversation, and really talk about some latest and great stuff you guys are doing. But you just sort of hit a neuron in my head. So let's curious your thoughts on this. No answer is completely fine. You mentioned universities, where this came from. All these organizations that historically have a lot of people on campus. Are you guys starting to change some of your techniques of how you are detecting, or is there any type of change you're doing in your algorithms recently as a result of COVID?
Oh, as a result of COVID?
Yeah.
Well, let's see. I don't think anything specifically with COVID. We're seeing certain industries. We're seeing huge upticks in traffic, like e-learning or video streaming and things like that. We're seeing a big uptick, but we haven't changed, as far as I know. We haven't changed our detection tactics in the last couple of months, specifically because of COVID. I mean, we're always looking at ways to keep one step ahead of the attack, or try to catch up in some cases, to be honest. But I can't think of anything off the top of my head specifically for COVID that we've been doing.
Cool. Just curious.
No, that's fair.
I do like that, because I want to segue from that question, go back a little bit, talking about to me was interesting here too, about what we're applying the WAF for, because we're not so much talking about, an attacker injecting garbage that's, pretty obvious, meaning here's a payload that's a pretty obvious cross-site scripting payload, a SQL injection, something that could pretty much be identified by regular expression. WAFs can obviously be a little bit more complicated than that. But in this case, we're talking about, like you were saying, especially the checking credit cards, just iterating through the CVVs until you get here's a valid one, just trying to do a single $1 charge against an endpoint, or even like video conferencing, trying to go through and enumerate and do something like Zoom bombing and guess that. These are very interesting types of attacks, because they're focusing on some of the application logic or application behavior, kind of what you were saying at the beginning. So it makes sense that the WAFs need to change and look for this behavior. So one of my questions too around that is that historically there were always concerns or objections that the WAF may slow things down, being in line and being overwhelmed. Now that you're bringing in a lot more potentially state management to look at the volume of requests to figure out what these requests are doing, do I need to be concerned, as someone who's possibly deploying this type of tool on my application?
Should you be concerned? Absolutely, in that you need to validate that the performance isn't going to cause any adverse effects. Our customers do that, and they've always, to my knowledge, they've pretty much always been happy that the performance has been totally acceptable. Is anything in line going to add latency? Of course, it's impossible for it not to if it's inspecting it in line. The question is how much. Typically, we see between 1 and 4 milliseconds of latency. I mean, that can obviously vary from request to request. But everybody should do their due diligence to make sure that the performance is in line. Our customers typically aren't seeing any kind of problems there because we're not an inline, choke point. Most of our customers roll us out in a distributed way, like their application. So there's a lot of ways you can deploy our solution. One of the more common ones is, let's say, plugging us in with your existing web server VMs or containers. So as those scale out, you're also scaling your security and distributing the load across the agents. So usually we see, single-digit CPU utilization, low footprint on memory. So usually performance is really a non-issue, especially even with these new rate limiting detections and rules. We do a lot of optimization around this. So our customers, to answer the question very quickly, our customers typically are not seeing any significant performance impact.
You might actually see some performance gains a little bit if you think about this logically, right? If I've got a bot that's trying to throw 100,000 credit cards at me in a minute, and I put rate limiting in place, guess what? I'm going to get some performance back, actually.
It's a lot less CPU intrusive to say, oh, I don't like this, I'm going to block it, versus letting it through and let the application process it and respond back. So you're right. There's a cost and a gain, and in those cases, the gain is usually better, more advantageous. I want to get back to your. Oh, go ahead, please.
Oh, just real quick on that. I'd be interested to see if you guys have done a white paper on that.
No, I actually we should now that you talk about it, because I mean it obviously depends on the use case, but I can definitely see where if you're sending requests, it's overtaxing the application, and it's getting worse. It's exponentially going up as the volumetric attack goes on. This is going to protect you, and that kind of is a perfect segue to application abuse, whether it's intentional or not. And a lot of our customers have that with their APIs. So let's say you have heavy APIs like for searches or queries or something like that, especially if they're open to the public, like a free trial for an application, and the developer can hit your API in a multi-tenant environment. These developers might get too aggressive, maybe by accident, with their queries. Maybe their Python script, if we go back to what we were talking about earlier, says, oh, I'm going to do this query for this large data set once an hour or once a minute, and they accidentally set it to once a second. That can have adverse effects for everybody in that SaaS environment. And they may not have done it on purpose, but the intent is almost irrelevant. The effect is the same, whether it was malicious intent or not. It could take down the application or bog down the performance of the application for everybody. So if you detect this and block it or stop it or throttle it and notify the security team so they can reach out to that abuser, again, whether the intent was malicious or not, you're protecting the application and all the other customers in a multi-tenant environment.
Mm-hmm. Well, I remember that back in the day working for one of the large security SaaS platforms. We had to paginate our results so we didn't give out too much data and stream it out. Trying to pull a few million vulnerabilities out of a SaaS platform can have its consequences.
I was guilty of that with the last company I worked for. I built an API integration for our own product, that a tool that our customers started using, and I accidentally set up polling to be too aggressive, and I took down part of our solution. So I've been guilty of this at my own company. So it's definitely something that's real out there, and a lot of our customers are trying to deal with.
Yeah, you haven't quite solved the humans make mistakes problem. So good luck with that. We'll see you.
Thank you.
We'll have you back in a year, see what the status is on that. I did want to add too, in the sense of the benefits here, because you mentioned earlier, talking about herd immunity or the network effects. That if a bot is targeting Matt's website and going through a bunch of carding, I get a benefit of that too, just because the reputation of that source has been tagged as attacking Matt. So when it hasn't touched me, or when it gets blocked from Matt's website and tries to come over to me, that source is already tainted. So there's a lot of benefits there, just from that network effect of the way this model looks like, this SaaS type of WAF. And I'd also point out that not only might you get some better performance increases by just being able to shed off a lot of bad traffic, you can also benefit financially by not incurring a lot of back-end charges or cost for just people running either successful or unsuccessful CVV checks, or having your upstream, the bank coming back to you and saying, it looks like we're seeing a lot more fraud. We're going to either charge you X amount more to take these card not present transactions, or we're actually going to say, if you don't, appreciably improve this, instead of just charging you more, you're too much of a liability. We're going to shut you off. So there's some direct financial consequences there. And I think the other thing I'd point out too, I want to go back to John's comment about how things have changed now. Unfortunately, the type of application abuse for music events and ticketing and ticket scalping has gone away a bit. So I do have my fingers crossed to go see some live shows sometime soon. But that's just another thing to point out, that there are lots of, to me, interesting ways that attackers have moved to attack attack applications. I'm using the word attack a little bit too much here, but to go after the behavior of the application and figure out how to monetize it. So carding, we're talking about different ways of monetizing it, ticket scalping and ticketing, ways of monetizing it. IDOR attacks, just generic, can I iterate through and find this open, unprotected meeting, video meeting, or here is a Google Docs are a little bit protected just because it's kind of hard to enumerate them because of that key space. But anything that's basically putting that authorization challenge into the obfuscation of the URL, meaning here's a nice randomly generated URL, and if you know it, you can get in, and if you don't, you can't. So these are just some other ways that, as we're talking, they're coming to my mind about more interesting behavior patterns and the different threat models, I guess is where I'm trying to go with that, about to consider for the application.
Yeah, the Google Docs example is probably the one that most people have seen, or a lot of people have probably seen. If you accidentally, or even on purpose, you can do as an experiment, create a Google Doc and make it public. Within sometimes a few hours, sometimes a few days, you will see random people popping up in that Google Doc because there are bots out there just scanning or enumerating through those Google Doc IDs looking for one that's open. And people post, accidentally make public very sensitive information in there. So that's an apropos example. I've had customers who talk about ticketing where you could buy tickets. I won't say what kind because I don't want to lead anybody to what customer might be, but a certain kind of ticket you could buy, and then you could go retrieve that ticket to print it out. And the way you retrieved it was a publicly accessible link, which had an order ID and a invoice ID. And those two IDs were separate. They were random, well, not randomly, but they were like 32 alphanumeric characters. They had to match up to the same record, but they found that attackers were enumerating through them and getting hits once in a while and hijacking somebody else's ticket, basically stealing it and then either using it for themselves or reselling it. And that was a problem, obviously. So they set us up to look for those attacks because, they're going to get a lot more hits than misses before they get the hits. So you look for excessive 404s or 403s or whatever those responses are to then stop them before they actually get to, maybe the 200 response saying this is valid, and then they can go sell that. So it's a very common thing, not just with tickets. I've seen medical records companies where I could log into the system, figure out what a patient ID looks like, log out of the system, and then start enumerating through those IDs and get hits and see medical information. And that's a huge cost to a company because now you're in a HIPAA violation. Every one of those hits is like, I don't know, thousands of dollars for every hit where I am able to extract patient data. So there could be a huge cost to these attacks besides the single record. It could also be reputation as well.
So we've also been talking about, you touched on briefly sort of the deployment model and different ways to scale it out, drop it in containers, et cetera. But talking there about compliance or different types, different consequences for this, who's been the audience that has been driving, driving these modern WAFs? And I'm asking this from the perspective that, of the new DevOps world. Has it still been security pushing for this type of tooling, these types of security methodologies or techniques? Or have you seen it coming from the developers and operations people themselves?
I think the lion's share is still security. That's just because that's where it's always been. But there's been a shift that's been growing over time that it's coming more and more from the developers as well. So you think of more modern development techniques. Not everybody is creating their own decryption libraries for different languages. You use the same library across your different applications, so you're not reinventing the wheel every time, and you have a consistent a way of encrypting and decrypting traffic. That's just a simple example. Or authentication. You have a central place for authentication for your different applications, so the developers are not having to deal with that, and it's consistent across your application. Security, yes, they should be using secure development techniques. But if you're going to have a central security model, you should have something that you can embed into the application, either at the language level, at the web server layer, or even above that, that is also consistent across your applications, so that the developers don't have to, again, reinvent the wheel every time. And that's where the developers are coming to us more and more when they see what our tool can provide, not just on the security side, but also on the feedback side. Show me where my application is being attacked. Show me where the broken links are in my application. Show me where people are attempting enumeration attacks. Even if I'm not vulnerable to it, they may not matter. I may think I'm not vulnerable, but if I'm getting attacked in a certain place constantly, maybe the attackers know something I don't. So I need to add more scrutiny to that part of my application because it seems to be a rich target. Does that make sense?
Yeah, absolutely.
Yeah,
and I think a lot of it too could be that the fact we've been talking about carding a lot, so I'll just continue with that, is that someone may use your the particular victim. We'll pick on Matt's website again. The bot may come over there, do the carding, but then the fraud, once they know that those cards are valid, they may not use them to spend on Matt's website. They may go over to John's, and that's where they execute the fraud. So it's really interesting too to be able to see where are people poking at these particular areas of the application, because as you were highlighting, it may mean the attackers know that here's the avenue to basically avenue to monetization, the avenue to make it interesting information that comes back to them that maybe wasn't the developers didn't initially appreciate.
That's something that I'm personally digging into a lot more. When we bring on a new customer, I look at their application and say, okay, if I was attacking your application, what would I go after? Yes, we're going to turn on detection of SQL injection, cross-site scripting, all that kind of stuff. You have to do that because that's still a large part of the attacks that you're seeing coming in. If you put an application on the internet, within 5 minutes, you're seeing those types of attacks. I'll look for areas of the apps of your app where I might try enumeration attacks. But then I start digging into the server errors that we're logging, where we don't see an attack, we don't see anything odd in the request, but I start digging into the errors to say, is there a pattern here that we're not detecting? So that's a treasure trove of information that I want to start mining. I do it now, just using my eyes, looking for areas to say, look, I think there's something going on here. So that's an area that I want to use to make suggestions to the client. We're already doing some of that today, but this is an area I think we could dig into more, and that security teams right now are sometimes really taxed. I mean, who wants to mine through application error logs? I mean, they're huge. That's something that has to be automated in some way to look for patterns that may indicate the attackers know something that you don't, that you're not detecting and you're not looking for.
Yeah, I think, Jack, you've definitely given us a lot of information to dig into. And given the sources of our reputation, thank you for not blocking us and taking the time to chat.
Thank you. I appreciate the time, guys.
Yeah, so thanks again to Jack. And we'll be looking forward to, we'll have to chat again when there's more about how to respond to some of these behaviors. So we'll definitely be keeping an eye out for that. And we'll have you back on. Also want to give a quick shout out to everyone in Discord channel chatting away and watching on our live stream today. And of course, I want to thank Matt and John for joining us. We're going to take a quick break and we'll return with our next interview segment.